Hello students, welcome to the class of Basic Electrical Engineering followed by the code Electrical 201. I am Priyanjali Mukherjee, Assistant Professor of Electrical Engineering Department of Narula Institute of Technology. This is the lesson plan. Here in this video lecture we will start our lecture 1, that is Introduction to AC single phase. So today we will discuss what is AC signal, what is the amplitude, the pure resistance, the peak, average and RMS values, form factor and peak factor, phase and phase difference, the concept of impedance and admittance. So what is an AC signal? So an AC or the alternating current is the current which changes periodically both in magnitude and in direction. It may be current or voltage, and it will be alternating if it reverses periodically in the direction, and its magnitude undergoes a definite cycle of changes in definite intervals of time. Now each cycle of alternating current or the voltage consists of two half cycles. During the first half cycle, it is flowing in one direction, and during the other it will flow in the opposite direction. Or if we express it in more restricted sense, then the alternating current is periodically varying current. Our average value of this period is equal to 0. Now the direct current always flow in one direction and its magnitude remains unaltered. In order to produce an alternating current through an electric circuit, a source capable of reversing the periodically EMF or AC generator is required, while for generating the DC in an electric circuit, a source capable of developing a constant EMF is required, which is maybe battery or DC generator. Now here we can see this one is the direct current where the magnitude remains constant and direction is also same. This one is the alternating current where magnitude and the direction reverses periodically, and next one is the pulsating DC where the magnitude is changing but the direction remains same. So when an alternating quantity goes through a complete set of positive and negative values through 360-degree electrical degree, then it is said to have one completed cycle completely. So now at present, a large percentage of the electrical energy being used for domestic and commercial purpose is generated as alternating current. And for industrial applications of direct current, which are the electrolytic process, welding process and variable speed motor drives, and the present trend is to generate AC and then convert it into DC by the converters. For conversion of AC into DC, the DC generator as a part of motor and generator, that is set, has to complete the SCR rectifiers and various other power control devices. These are usually cheaper in cost, compact in size, relatively noise-free in operation, and require minimum maintenance. Though they can suffer from some disadvantages such as the poor power factor, harmonic generation, poor braking, like this. Now in our country, the standard voltage for low tension distribution is 240 or 415 volt. That means 240 volt between phase and neutral wires and 415 volt from line to line. And this is reasonably safe voltage. The higher the voltage used, lower is the installation cost. That means the economy is achieved, but increase of voltage means more hazard to human life and property. So all over the world, the standard voltage used for the low transmission distribution in the range of 200 to 350 volt to 250 to 440 volt. And the generation, transmission and the high tension distribution voltages are governed by the economy and its operation. So now almost the whole of the vast amount of electrical energy used throughout the world for every purpose is generated by alternating current generators. So this is not due to any superiority of the alternating current over the direct current in case of the applicability to industrial or domestic use. And there are certain type of works for which alternating current is unsuitable, and therefore the direct current is absolutely necessary, such as the electroplating, the charging purpose of the storage batteries, refining of copper, aluminium, electrotyping, etc. So production and industrial gas also comes under this. Now some power applications, the AC motor is unsatisfactory. Maybe for the rolling mills, paper making machines, high speed elevators, or automatic machine tools, or high speed printing presses. Now direct current required for these applications. Now the AC generator have no commutator, and so it can be built in very large units to run at high speed, producing high voltage. It may be 33 kV. So the construction and operating cost per kilowatt is very low, whereas DC generator capacities and voltages are limited to the comparatively low values. Next is alternating current can be generated by high voltages and can be raised and lowered by static machine, which is known as the transformer, which we will discuss on the next videos. And it makes the transmission and distribution of electrical energy economical. And in case of DC current, use of transformer is not possible. The AC induction motor is cheaper in initial cost and maintenance, as it has got no commutator, and more efficient than the DC motor for constant speed one. So it is desirable to generate power is the alternating current. And maintenance cost of AC equipment is also lesser, and in case of switch gear for AC system is simpler than it is required in the DC system. The high transmission efficiency in AC, that generation of electrical energy economical by generating it in large quantities in a single station and distributing over a large territory. So these are the main reasons of generation the electrical energy in the form of alternating current. Next is amplitude. So when we are considering a sinusoidal wave, it is expressed as A max sine omega t, where the A max represents the amplitude of the given system or the equation. Now the amplitude is nothing but the vertical distance between a peak or a valley and the equilibrium point. So the alternating quantity, which is one in which the changes in magnitude and alternation of direction at regular interval of time occurs, and it rises from 0 to maximum positive value, falls to 0, and increases to maximum in the reverse direction and falls back to zero again, and the EMF or the voltage and current repeat the procedure. So there are few terms in case of the alternating quantity, among which the first one is waveform. So you are looking that there is one wave. Actually there are two complete cycles. Now the shape of the curve of this voltage or current when it is plotted against the time is called the waveform. So here the x-axis represents the time and y-axis represents the magnitude. Now the waveform of an alternating voltage varying sinusoidally, and this waveform of this induced EMF in an alternator differs slightly from the sine wave, but for calculation it has to be considered as mx sine omega t. Next is the alternation cycle. Now when a periodic wave such as the sinusoidal wave goes through one complete set of positive or negative values, it completes one alternation, and when it goes one complete set of the positive or the negative values, and it's said to be one complete cycle. An alternation and cycle can also be defined in terms of the angular measurement. One alternation corresponds 180 degree, or 180 degree means pi radian, whereas one cycle corresponds to 360 degree, or that is equal to 2 pi radian. And next is the time period and the frequency. The time taken in the second by the alternating quantity to complete one cycle is known as the time period or periodic time, and periodic time is represented by capital T, whereas the number of cycles completed per second by an alternating quantity is known as the frequency, and it is denoted by F. And this SI system, the expression is known as the hertz, and 1 hertz is equal to 1 cycle per second. That means we can write F equal to 1 divided by T, where T represents the time taken in completing one cycle. So next is the pure resistance. What will happen if we add one pure resistance with the AC sinusoidal supply? So if we consider the DC, then we can say that due to the DC supply, the current flow through the resistance will be in DC. But now we are adding a pure resistance across the AC supply. So when a pure resistor is connected with it, then due to this electrical resistance property, the current flow through it at any instant is directly proportional to the instantaneous applied voltage and inversely proportional to the resistance value. Now as the voltage is varying sinusoidally, the resistance is constant value, the current flow through it will be a sinusoidal wave, and it can be in phase in the applied voltage, because this one voltage signal, it is represented by V sine omega t, and I is equal to V divided by R. So I equal to V max. If we consider the maximum voltage is V max, then V max divided by R into sine omega t, and this I is equal to I max sine omega t. So as I is equal to V divided by R, that's why the maximum I value must be less than maximum V value, but both are originating from the same time and both the cycle completes at the same time. So we can say there is no phase difference between this voltage and current signal in case of pure resistance. Next is the power in the pure resistor. So power is actually the multiplication of voltage and the current. So V maximum into I maximum represents the power, whereas the P equal to V into I, or we can write I square R, that is equal to V square divided by R. So when we are calculating power, we will consider the RMS value, and what is the RMS value we are discussing in the next slide. So here you can see that this one is the voltage signal and this is the current signal, and every instant we are multiplying the voltage and current. So during the first half cycle, the voltage and current both are positive. That's why during this cycle the current power is also positive cycle. Whereas for the next half cycle, the current and voltage both are negative. So multiplication of these two gives us a positive. So we can conclude that for a pure resistor in an AC circuit behaves is exactly in the same way as it is works as the DC circuit. Next is the peak value, average value and the RMS value. Now the peak value is nothing but the maximum value, and it may be represented as Vmax during one cycle, and also it is known as the peak value, or it is also known as the crest value. Now the average value of alternating current. Now the average or mean value of an alternating current is equal to the value of direct current which transfer across any circuit the same charge as it transferred by that alternating current during the given time. Since in the case of symmetrical alternating current, symmetrical means one whose two half cycles are exactly similar, whether sinusoidal or non-sinusoidal, and the average or mean value over a complete cycle is 0, because alternating quantities average or mean value means the value determined by taking the average of instantaneous values during half cycle or the one alternation. So for unsymmetrical current, half-wave rectified current, the average value means the value determined by taking the mean of instantaneous value over the whole cycle. So the average value is nothing but, if we consider n number of all times, then I1, I2, I3, and summation of I1, I2, I3 up to In divided by total n. N is length of base over one alternation, and I1, I2 is equal to area of the one alternation. So in this way we can find out the average value of a sinusoidal wave. Next is the RMS value, or the effective value of the alternating current. Now the RMS or effective value of an alternating current or the voltage is given by the steady current or voltage when it flows on applied to a given resistance for a given time, produces the same amount of heat when the alternating current or voltage is flowing or applied to the same resistance for the same time. Or in other words, we can say RMS value is defined as the square root of means of squares of instantaneous value. That means if it is represented by I effective, then it will be root over of I1 square plus I2 square up to In square divided by n. Now effective value or the virtual value of the alternating current or the voltage is equal to the square root of mean of the squares of successive ordinates, and that's why it is known as the root mean square or RMS value. So here we can calculate what is the RMS value. That is, if we consider the first interval, then heat produced during the first interval is I1 square RT divided by n joules, and heat produced by the second interval, it will be I2 square into R into T divided by n, like this. So the total heat produced is equal to R into T into I1 square plus I2 square plus In square by Jn. So now as we can I consider the I effective, then the heat produced by the current and this time T is equal to I effective square into RT divided by J. Or you can write I effective equal to root over of I1 square, I2 square plus I3 square up to In square whole divided by n. This is known as the mean of the squares of the instantaneous values or the IRMS. So next is the form factor and the peak factor of a given sinusoidal wave. Now the form factor and peak factor is actually convenient to have calculations, and for form factor we will consider it is the ratio of effective value to the average value. Now at the first, upon the mean value of the EMF over a half period, therefore it becomes essential to have some means of connecting this value with the effective or RMS value. So the knowledge of form factor, it is defined as the ratio of effective value to the average or mean value of the periodic wave. Now the form factor equal to, we can say, E M by E average, or it can be written is equal to 1.11, or IRMS is equal to I max by root 2 and I average is equal to I max divided by pi. And IRMS also, it can be represented at voltage, that is VRMS divided by V average. So it is fixed, and this one is 1.11 for 50 Hertz supply. Next is the peak factor. So knowledge of peak factor of an alternating voltage is very essential when it is used to find out the dielectric strength, because the dielectric stress developed in any insulating material is proportional to the maximum value of the voltage applied to it. So the peak or crest or the amplitude factor of a periodic wave is defined as the ratio of the maximum of peak to the effective or the RMS value. So peak factor is nothing but I max divided by R max, or V maximum divided by VRMS, and if we put the values, so it becomes 1.414. So peak factor is also constant, it is 1.414, and form factor is also constant, it is 1.11 for a given sinusoidal wave. Next is the phase and phase differences. Now the phase is defined as the position of the waveform at a fraction of time period, and it is expressed in the angle. And phase can be an expression of relative displacement between two corresponding features of two waveforms having the same frequency. Now phase difference is difference between two waves which having the same frequency and refer to the same point in time, and it is expressed in degrees or radians. So here we can see there are three waves. The red one has been started from 0, the blue one has been started before it, and the yellow one has been started more 120 degree before it. So here the R phase starts from 0 degree and B phase starts from 120 degree from R phase of the electrical circuit. Hence the phase difference between these two is equal to 0 minus of 120, that is equal to minus 120 degree. So in this way we can calculate that the yellow one is 240 degree before, so it will be minus 240 degrees difference. That means the difference, phase difference between the blue and the red is 120 degree. The phase difference between the yellow and the red is equal to 240 degree. Next is the concept of impedance and admittance. Now the impedance extends the concept of the resistance to alternating current and possesses both magnitude and phase, unlike the resistance which has only the magnitude. And impedance is a complex number. It is represented by Z. SI unit of it's equal to ohm, and it can be written in magnitude and phase, that is in polar form, Z angle theta. And admittance is the inverse of this impedance, and Y is represented by admittance, and unit is Siemens or mho. Z is the impedance, it is measured in ohms, and we can write Y is equal to G plus JB, and G represents the conductance which is measured in Siemens, and B represents the susceptance, it is also measured in Siemens, whereas Y is represented by the admittance, and unit of the admittance is Siemens or mho, and that is equal to 1 by ohm. I hope after this video lecture you have a clear idea about today's topic. Now we will go through some question answer session in context of this video lecture. So you are requested to go through it gradually and solve the questions by your own. The answers are attached at the end of each question.